Hey guys, welcome back to another episode of the Weekly Coder. I'm Chris, and today we are going to continue from where we left off, which is a bit of a mystery to me. You would think that after a week, I would be able to remember where it is that we left off, but, you know, I guess I don't know. Maybe I'm getting old. Maybe I just have too much shit to think about on a daily basis that I just can't remember what we did, or what I said we were going to do this week. Maybe I should have looked back first before I started recording. All these things that I could have done that I didn't do. But oh well, here we are. We've got Unity open. We are on episode 3. And so I'm just going to press the play button and see where we are. We obviously set up everything when we have a Frogger here. And we have movement. Okay. And the Frogger actually moves the way he's supposed to, and he turns around like he's supposed to, and oh, he disappears. Alright, so we obviously did that too, which is cool. So he moves behind, yeah, he moves behind the bar, which is good. Because we'll need that when we implement like the lily pads and the logs that like float on the water. Because he's going to ride on them, and he's going to have to disappear as the log goes off the screen, and he's going to have to reappear on the other side. So we're going to do some hacky things to make that work. So where we are is here. We need to make it so that Frogger can't go past here. Okay, so we need to set some boundaries, which is actually a lot simpler than you might think. We're not going to do any collision detection. We're basically just going to open up the player script. And since this level is a specific size, we can basically use those values to our advantage. So what we'll do is, alright, so we see here how we can move down, we can move up, we can move down, we can move left, and we can move right. So if we're moving left or right, we need to make sure that we can do that as long as our position isn't greater than the boundary. So, and I believe that that number is 6, if I'm not mistaken. But we can figure that out. If we go back to Unity and we press the play button, there's 2 ways we can figure that out. One is the slow way, where we just go 1, 2, 3, 4, 5, 6, 7, 8, right? So we're at 8. That's where we want to be, or that's as far as we want to allow the player to go. Now if we click on the player game object, you'll see that his position is 8. So really all we would have had to do is just go from 0 to 8, or to where we wanted to be, and then look up here in the inspector, and it'll tell us, okay, well, this is where we're at 8. Coincidentally, since we are also going to limit his movement in the y direction, we can see that where we are at is -6 in the y, which means that that is as far as we're going to want to go south. Okay, we don't want to go any further down than -6. We don't want to go any further right than 8. And since we were at 0 in the middle, the opposite to that would be left, right? And that would be -8. And you can see that if I, if I go all the way to the left, and you look in the inspector, you'll see now that we are at -8. So we want to limit the movement in the left direction to -8. We want to limit the movement in the right direction to 8. And we want to limit the movement in the I said that wrong. The right direction is 8. The left direction is -8. The y direction, which is down, is -6. Which also means that the top should be 6. Although we shouldn't need to limit the top, because at the top we're going to have some collision detection to check to see what he's actually hitting. Because if he's hitting this, he should die. If he's hitting this, then he should win. Also, if he's hitting this, he should also die. So there's no point where we ever need to check to see if he's higher than 6, because technically you should never get there. Alright, so let's go ahead and stop this and open up our script. So what we'll do is, for the up arrow, we just won't care. For the down arrow, we're going to check and make sure that we are at -6 and not more than that. So we're going to say as long as if position, which basically if is basically saying as long as the position dot position dot y is less than or equal to, or less than -6. As long as it's less than -6, or actually this would be, in this case, yeah, less than -6. Greater than -6. Less than -6. As long as it's less than -6, we are going to allow this position to be updated. All right. So in order to test that, let's just go ahead and click play here and see what happens. All right. So we're in play mode. We can go up, we can go down, and yeah, I'm gonna guess that that was greater than -6. So let's go back to our script. Because less than -6 would be a -7. Because -7 technically is a smaller number, even though the number itself, the digit, is larger. So here, we can't go further down, and that is me pressing the key. You can tell we can't go further down. But we can go up as far as we want. When we go down, we get stopped right here. All right. So now we just have to implement that for the x-axis. So when we move left or right, for instance. So if we're moving left, we want to say -8. So if position.y, so as long as the position.y is greater than -8, we can continue to move left. And then we'll do the same thing for moving right. We'll say if, as long as, the position.y, and we are not dealing with the y position. Damn. Position.x for both of these. So position.x is less than 8. So as long as position.x is less than 8, we are going to do this. And I don't know why I put this in parentheses. There we go. So that's what that should look like. Now let me just tidy up the spaces here. Alright, that's better. Okay, so just to kind of go over this again, what we did here is we're checking to see if the position, the y position, is greater than -6, meaning it can be -5. It can actually be -6. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, all the way up to infinity. As long as it's greater than that, we are going to allow position to be incremented by 1 unit in the down direction. All right. Same thing for left. As long as the position x is greater than -8, meaning -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, infinity, we're going to allow to continue left. And then for moving right, we're going to just make sure that the position.x is less than 8. Okay. Then we allow the movement to the right. So now let's see if that works. And here we go. We are stuck. We can go up as far as we want, but we cannot go to the side and disappear like we were. Okay, so this is basically, now we are restricted to a box as long as we're not going up, because if we go up, we can go to infinity. Now, here's something interesting. If we look at the scene view, we can see ourselves up here. All right. Now I'm going to prove to you that this is not any kind of collision detection, because we're basically outside. Right. So I'm just going to drag my scene panel over here so that we can look at both the scene and the game view. So I can move my frog. So you can see him in the scene view because we're not looking at the camera when we look at the scene view. So we see things that the camera can't see. Right? So we still can't go outside of that right or left bounds. We're still constricted to being able to go only -8 in the x direction and 8. So that's it. We're just that's our limitation. So let's go down. All right. So apart from the movement and the, actually let me put this back. All right, and let's do that. All right. So apart from the movement and the restriction, whatever you want to call it, to basically prevent Frogger from leaving the game. So the jail, we just built a jail for him. What we're going to do is we're going to create a new object, a new class. So, and that class is basically going to be a class that we're going to assign to every object. And what we're going to call this is, I'm just going to right click here and we're going to click create, and let's go with C# script, and we're going to call it Collidable object. Collidable object. All right. So let's open that up. So the way that we're going to do collisions is we are going to use a method that is a part of the rect class that is going to allow us to just basically check to see if two rects are overlapping. And I'm going to get to and explain that in just a second. But first what we need to do is let's create a method, and we're going to make it public because this is actually going to be called, oh man, frigging Visual Studio. This thing has like been nothing but a nightmare for me. So we're gonna make this a public, and it's gonna return a boolean, and we're gonna call it is colliding, and we're going to pass in a parameter, and that's going to be of type GameObject, and it's going to be the player GameObject. Okay, so what this means basically is that the player or any other object can call this object and to see if it's colliding with itself. So now what we want to do is we want to create a couple of variables that we're going to use. And I'm going to start with, you know what, let's just create them all. We're going to create a rect that'll store the player's rect. We're going to create a vector2, and that is going to store the player size. And another vector2, which is going to store the player position. And you're probably wondering, if you know anything about rects, why am I creating a player size and player position, since basically that is contained within the rect? Well, that's a good question. And the reason that I'm doing it is because I don't want to go player rect dot size dot width or player rect dot position dot height or the position dot x position dot y. I'm just going, basically I'm making the variable shorter so that when we write all this code, we don't have to worry about the variables being like, you know, I don't know, long, I guess. God, that's a stupid word. So now we're going to do a rect for the collidable object. So collidable object rect, and a rect, or sorry, a vector2 collidable object size, and another vector2 for collidable object position. Alright, so we actually don't need the start and update methods, so let's get these out of the way so that they're not bugging us. And the first thing we're going to do is we're going to set player size. We're going to set that equal to player game object. And we're going to take the transform and we're going to get the sprite renderer component, since that contains the bounds property of the sprite, or the size property, sorry, the size property of the sprite. And that's basically going to get us the width and height of our player, and it's going to store it in a vector 2, which is going to have an x and y, which is kind of confusing because, you know, they're coordinates instead of sizes, but just bear with me. We're going to use x and y for width and height. So now we're going to get the player position, and it's going to be kind of the same thing. It's going to use the player game object, and we're going to get the transform and the local position of that transform. So the player game object that I'm referring to here is basically this parameter that we're passing in when we're calling this method. So let's just say the player is iterating over all of the objects in the game, in the scene, and is calling the isColliding method on every single one of the objects that he's iterating over. What he would then do is he would just pass himself in as the game object, and then that allows us to basically you know, utilize his transform and get his information, and then figure out if he collides with. And you know, it's probably a bad assumption to call this player game object. We should have just called this other collider, or other collision object, or testing object, but we're assuming that the player is the only object that is ever going to call this, which you know, I mean, it should be okay, because, you know, cars don't need to know if they're colliding with other cars or the bounds of the screen, or logs don't need to care. Nothing cares if it collides with anything other than the player. So the player is the only thing that's ever going to check for collisions. So therefore, we just call it player game object. All right, no more of that. Now we're going to go and set the size, or store the size of the collidable. So basically, that's just going to use get component, sprite renderer, and size. And we're going to do the same thing for the position. So we're going to say get component, sprite, or nope, transform dot local position. All right, so we've got the size and position for both the player and for the sprite that is a part of the game object that we are testing the collision against. So now what we're going to do is we're going to create the rects. So basically the rects are just going to hold the size and positions with some adjustments. So what we're going to do is we're going to create a new rect, and the rect has some overloads. We have 4 of them to be exact. We have one that'll just take a rect as a source, so we can create a rect from another rect, or we can create a rect with a position and size, or we can create a rect with a an x, y coordinate, and a width and a height. So it's position, size. So I mean, it's not too complicated. So what we're going to do is we're going to use x, y, and width and height to create our rects. So the way we do this is we're going to do it player position dot x minus player size dot x divided by 2, and player position dot y minus player size dot y divided by 2, player size dot x, player size dot y. So the way this rect works is it stores the position, x and y position. Okay, so this is the x coordinate. So if you'll remember that the player position is being basically assigned to the origin, for instance, of the player position is always going to be in the middle of the sprite. So that's why we divide it by 2. So we're subtracting half of the player's width and then setting that as the x position. And we're subtracting half of the player's height and setting that as the y position to get that top or bottom corner of the sprite. And then we're setting the player size.x and player size.y values as the width and height of our rect. All right, we're going to do the same thing for the collidable object. So collidable rect equals new rect. And that's going to be collidable object position dot x minus collidable object size dot x divided by 2. And then we'll have collidable object position dot y minus collidable object size dot y divided by 2, and collidable object position, or sorry, size dot x, and collidable object size dot y. All right. So now that we have a rect for both the player and the object that he's trying or checking to see if he's colliding with, all we simply have to do here is we have to say if object, if collidable object rect, so we're calling the rect, and then we're going to call a method on the rect, and that's just basically overlaps. Okay, and let me just come back here a little bit. If we look at overlaps, and you can read here, it says returns true if the other rectangle overlaps this one. If allow inverse is present and true, the widths and heights of the rects are allowed to take negative values. The min value is greater, i.e. the min value is greater than the max, and the test will still work. And this is actually really, really important for our scenario because we need to be able to test in the negative direction because our x doesn't start at 0. Our x starts at -6 and -8. Sorry, our x starts at -8 and our y starts at -6. So we do have some negative values to test for and to see if we overlap with, for collisions. So we have to make sure that we specify true as the overload, and that is that one here. So if we do overlaps and then we look at the overload here, is it basically we can assign a true value to allow inverse because that is set to be false by default. So now we just specify the other rect, which is the player rect, and then we do a comma, and then we just say true so that we can allow that inverse. And we say if that's true, right? So if the collidable object overlaps the player, then we return true. Otherwise, we just return false. And we don't have to write else here because once we return true, nothing else in here will run. So everything that comes after the word return here and true, if we're in this if statement, if this is true and we're here, we return with a true, that means that everything after that will not run. It'll just return true for this Boolean when we're calling it. So when we're calling is colliding, we want to store that in a Boolean variable, and then we want to check to see if that Boolean variable is true or false. Okay. So we're going to save this. And we are going to assign it to all the objects that are collidable. So let's go back to Unity and check out which ones those are. So we've got the danger zones, which are... Oh, we're in the game view. All right, so we've got danger zones here, right? These are all going to be collidable. We got safe zones. These are also going to be collidable. We've got these borders, which we don't care about. We've got, we've got that, which we don't care about. We also have the water, which is also collidable. All right, so let's start with the water. Let's just take the collidable object script and we're just going to throw it on there. All right, and then let's go see. We didn't need grass, border, border, safe zone. I'm just going to go through and highlight all of these together. And then I'm going to take this and throw it up here. Now if you look, you'll see that they all have that collidable game object, or a collidable object script. So there's one thing that we should probably do though, and that is we need to know, we know that these are collidable objects, but we need to know if they are safe or not safe, right? So these, for instance, are safe. These danger zone objects are not safe. And this water is also not safe. So let's go back into our script and let's add some more variables. And these are going to be public. So public bool is safe. And that's basically going to tell us whether or not it's a safe place for us to be. And I think we're just going to leave that there for now. That's all we need to know. So the danger zones are not safe, so we're not going to check those as being safe. The safe zones, however, let's highlight all of these, and we're going to check as safe. The water is not safe, so we're going to leave that unchecked. So now we can go back to the player script, and now we'll be able to create a method called check for collisions. We'll do that, make it private, and we're just check for or check collisions, and that's not right. Alright, so we're going to check collisions, and you know what my problem is I'm like between platforms writing code on a Mac, and I've been coding a lot in Objective-C for the last week. So switching back from Objective-C to like C# has been, it's a nightmare. And actually switching from C# to Objective-C is even worse. So we're going to check collisions, and we're going to call that in the update loop all the time. Check collisions, because we always want to know if we're colliding. And what we're going to do is we need to basically get all of the objects to collide over, right? And what we the way we do that is, we should probably make it easier on ourselves, and we're going to add a tag to these objects. So like this, for instance, anything that's a collidable object, we're going to tag it. See, right now it's untagged. And we're not going to use a pre-made tag. We're just going to create a tag. And we're going to click the plus here, and we'll call this collidable object. So now if we go back to danger zone, and if we go down here, we can see we have collidable object as an available tag to use. So we'll call that. And then anything that's an object that we can collide with, we're going to go ahead and select. So the water, all the safe zones, and all the danger zones, and we're going to tag them as a collidable object. So now if we go back into our script, we can simply say game object, game objects equals game object, find game objects with tag, and then we're just going to pass in collidable object. So what that does is it's going to check the scene, and it's going to say, hey, I want all of the game objects that have the tag collidable object, and I want to store them in the game objects variable right here. So now we have an array of game objects with the tag collidable object. So now what we can do is we can say for each of those, so we start with a for each loop. We can say for each game object, and we'll just call this GO for game object, in game object, game objects. Right? So for each loops are great. Basically what we're doing is we're creating a game object and calling it GO for every game object in this array. All right, so every time this iterates, it's going to create a new game object from this array in the next iteration. Very simple. We then say collidable object, and we're going to say collidable object. I love how Visual Studio suggests variable names. It's kind of cool, actually. So collidable object equals go.getComponent and collidable object. So that's just the script that we created. So it's the class. It's actually the component according to Unity's naming standards. So now if collidable object dot is colliding, all right, so here we're calling that method that we created. And we're going to say this dot game object because the player script is on the player. All right, so here we're testing because remember this is colliding is going to return true or false. So we're going to say if collidable is colliding, meaning hey, am I colliding with something or not? And if I am, then we're going to check to see if the thing that we're colliding with is an actual safe object, right? So we're going to do collidable object dot is safe, right? So if it's safe, then we don't really care. Then we don't really care. Otherwise, we do care. But just for the heck of it, let's do a log and say safe, right? And not safe. Okay. All right. So with that, we should be able to hop around the scene and we should be able to determine whether or not objects are safe. So if we go to console, all right, notice that we're not interacting with any collidable object at the moment because we're not getting any log output. So if we go here, the second that we jump onto water, we should be getting, there we go, see? And we get this not safe message. So now, let's go ahead and let's collapse these so that the not safes just show up. All right, so you see they're still counting up. We're still not safe. And now we're safe and not safe, which is cool. So now we're just safe. See how the safe messages are still counting up and the not safes have stopped? That means that we are now on a safe spot. Now we're not on a safe spot. And now we're on a safe spot. So this is working exactly as intended. And now I think that we've gone from, oh crap, the video is too short, to, oh crap, I think the video might be a little too long. We need to end the video here, and then next week we'll pick it up, and we're actually going to flesh out this whole collision shit. We're going to make it so that if we collide with something, we die, and we go back to the beginning. Maybe that'll be the entire episode. It's going to end up being a short one again. I have to figure this out. Anyways, hope you guys enjoyed the episode. I will see you guys next week. Don't forget to subscribe, hit the like button if you liked the video. If you didn't, hit the not like button, whatever. Yeah, so anyways, again, I'm just going to say this one more time. Subscribe to my channel. Subscriptions are cool, and they let you know when I put new content out. So, oh, and by the way, if you do that, you also want to check the bell for notifications, of course, because without that, you're not going to get notified. You're not. You're going to get, when you go to YouTube, this is how this works. If you subscribe to a channel on YouTube, then basically when you go to YouTube, you can see your subscribed to channels and you can see the videos that they put out. And you can go to subscribed and you can see all of the new content that that the creators have published. But if all you do is click on subscribe, but you also want to be notified when the creator puts out new content, then you have to click that notification bell. Otherwise, you're never going to get like an email or any kind of other notification to let you know that there's new content to watch. Now with me, I usually put new videos out weekly, so you guys, just come up once a week to see new videos. It's fine. But still, I might someday surprise you and put out more than one video. And then where will you be? You will not know. So therefore, click the bell so you'll get notified. Anyways, subscribe, click the bell. See you later. Have a good time with the video. And let me know how it goes. If you have any questions, feel free to leave them in the comments and I will check them and hopefully answer them if I can.